Welcome back to QFitsView. In this video we'll be talking about manipulating data arrays using the DPUser commands. You can define arrays and subarrays through ranges. On this spectrum example, which is buffer 2, I can isolate the hydrogen beta O3 complex in the spectrum by selecting the pixel range. For example, I would say something like, in the DPUser command line, PR for pixel range equals buffer 2 with square brackets to define the range, and I put 982 with colon 1410, which is how you define the range. And I actually know the pixel range I want, and do close square brackets, then press enter. As you can see, we've isolated the range. This new variable has got the x-axis minimum and maximum pixels. They start at 1 and go to 429 with the corresponding wavelength range 4724 angstroms to 5127 angstroms. You can also do this for 2D or 3D data. As an example, I can load up my image example 1, and you can create a new image just surrounding the galaxy core like this by doing the command, say, buffer new, as the name of the new buffer, equals buffer 3, which is the image I'm working with, square brackets, star, which is the whole range for that axis, in other words, the x-axis, and then 50:90, which is the row range in the y direction that I want to select. Close brackets and press enter, and as there you can see the new variable restricted to the range that we want. In a similar manner, I will extend this to 3 dimensions. For instance, I'll display the cube example, in this case, buffer 1. I extract the subarray I want, say, buffer new again equals buffer 1 square brackets star comma star, that's the x and y axis, I accept the whole lot of these, comma 970 to 1100, that's the pixel range that I want, press enter, and this is the Passion beta line, as you can see with all its structured detail as I move over the cube. We can also use ranges to create arrays. For example, I could say x equals bracket 0:360, and I'm creating 1D data like that in the range of 0 to 360. I've made a simple vector with the numbers 0 to 360. You can then use that in a function. For instance, I could say y equals sine x, with the option to use the degree form of the sine function. As you see, I produced a sine function. We could then save this command S as a fits file, say sine.fits, and that's saved. That's all for this video. Check out other videos on our YouTube channel.